Section 2.4, Linear Inequalities and Problem Solving. Linear inequalities are basically an equation, except you have one of these symbols, an equality sign. So if we have the equation x equals 3 or 12 equals 7 minus 3y, these are the versions of inequalities that we could have. Just interchange all the symbols. So objective 1, use interval notation. A solution of inequality is a value of the variable that makes the inequality a true statement. So the solution set of inequality is the set of all solutions. You don't always have one solution because an inequality is less than, greater than, equal to, or greater than or equal to, less than or equal to. So it's a range of numbers that could fit into this. So just take a look at this chart, and I highly suggest writing it down because it'll help you with interval notation and what directions we're graphing it, why we're graphing it that way in the upcoming examples. So make sure you copy this down. Moving on to example 1. So example 1 wants us to graph each inequality on a number line, then write the solution in interval notation. So for A, we have x is greater than or equal to 3.6. Well, on a number line, that states that x is anything that's greater than 3.6. So if we have 3.6 here, it's greater than. But since we have the greater than and equal to symbol, we need to use a parenthesis, or excuse me, a bracket. So we use our bracket, and we're going to any number greater, so we go to the right. Because remember, on a number line, we have 0, 1, and negative 1. To the left are all our negative numbers, and to the right of 0 are all our positive numbers. Alright, B. So B says x such that negative 6 is less than x, and x is less than or equal to 11. Nope, I forgot to write that. Number A is, or letter A is an inequality, or interval. So as an interval, we're going from 3.6 to infinity. So it's 3.6 to infinity. Infinity is always a parenthesis, and since we used a bracket, the bracket goes to 3.6. Now here, let's do a number line. So our number line, we have two values, 11 and negative 6. 0 is somewhere in between there. So it states that x has to be greater than negative 6, but it has to be less than 11. So for negative 6, that is a parenthesis. And for 11, that's a bracket. And we're going to connect the two for our number line. Now we have to write an interval notation. Since they go together, we're going to have parenthesis, because of the negative 6, to 11. And that's a bracket. Moving on to C. So C and D, we're not going to graph on the number line. We'll just write an interval notation. I think you get the picture. So we have 1/2 x minus 3 is greater than 4. We need to solve for x here. So to solve for x, we're going to add 3. So we have 1/2 x is greater than 7. And then we need to get rid of this 1/2 by multiplying by 2. So we have x is greater than 14. So that means I want any number that's greater than 14. So in interval notation, that's 14 to infinity. And we use parentheses because of our inequality sign. Alright, last, D. We have x plus 1 over 4 minus 2x plus 1 over 3 is less than negative 2. Now we can approach this two ways, but I'm teaching you this way that we're going to do for this example because it's how we're going to treat fractions from now on. We're going to get rid of them. So let's get rid of the fractions. We can get rid of the fractions by finding the LCD of all the denominators. So our denominator, we have 4, 3, and 1. So 4 and 3 have 12 in common, so our LCD is 12. And we're going to multiply that to every single numerator we see. So we have 12 over 1 times x plus 1 over 4 minus 12 over 1 times 2x plus 1 over 3 is less than 12 over 1 times negative 2 over 1. So what that allows us to do is cancel out the fractions, because I know we don't like working with them. So always diagonally we can cancel out. So 4 goes into 12 3 times, 3 goes into 12 4 times, and there's nothing on the right side. So we have 3 times x plus 1 is minus 4 times 2x plus 1 is less than negative 24. Now we're going to distribute, and after we do that, we're going to combine like terms. So we have 3 times x is 3x, 3 times 1 is 3, minus 4 times 2x is 8x, and then negative 4 times positive 1 is negative 4, and that's less than negative 24. We're going to combine like terms here, so x's with x's, numbers with numbers. So we have negative 5x minus 1 is less than negative 24, still solving for x. So we add 1. We get negative 5x is less than negative 23. Divide by negative 5. So we have x is now greater than 23 over 5. Be careful when we divide by a negative. We need to flip the sign. If you divide or multiply by a negative over an inequality sign, flip the sign just like we did here. Now to write this in interval notation, it says x is greater, so that means we have 23 over 5 to infinity, and they're both parentheses. Alright, that's it for this section.